In this lesson, I'll show you 3 examples on how to perform the substitution rule with integrals. This is part 3 of the series. The first question reads, find the integral of x to the power of 3 plus 3 to the power of 6 times 3x to the power of 2 dx. The first thing that I'll do is substitute part of this expression for u. Usually, you want to choose the factor that is more complicated in the expression. For example, take a look at x to the power of 3 plus 3 and take a look at 3x to the power of 2. Of these two, 3x to the power of 3 plus 3 is more complicated because it contains 2 terms, whereas this contains 1. So I'm going to set u equal to x to the power of 3 plus 3. I'm not going to rewrite this yet. My next step will be to find the derivative with respect to x. So if I find the derivative with respect to x, I end up with du over dx, and I'm doing this implicitly. This becomes 3x squared, and this constant becomes 0. Next, what I'll do is solve for dx. To solve for dx, I'll multiply both sides by dx. That cancels this. And then subsequently, divide both sides by 3x to the power of 2, where I end up with du over 3x to the power of 2 is equal to dx. The reason why I did this is because now I can change this with u, because I assigned it as u, and I can also change dx with du over 3x to the power of 2. Here's how the new expression looks like. We have the integral of u to the power of 6, 3x to the power of 2, times du over 3x to the power of 2. Watch what happens. This 3x to the power of 2 and this cancel out, leaving us with a very simple integral. The integral of u to the power of 6 du. We can easily find the integral of u to the power of 6. In fact, all you do is add 1 to the exponent and divide the whole function by that sum. If I add 1 to 6, I end up with 7 over 7, and that's it. I just found the integral plus c. Of course, you can't keep it in terms of u because the original equation was in terms of x. So what I have to do is replace u with what I set it as at the beginning, which was x to the power of 3 plus 3. Therefore, our final answer, which I'll represent as big F at x, is equal to x to the power of 3 plus 3 to the power of 7 over 7 plus c. Let's move on to question 2. Question 2 looks really similar to question 1. The only difference is that we have x to the power of 2 instead of 3x to the power of 2. Let's see if that changes anything. Once again, I'm going to set this part as my u because it's the more complicated of the two factors. So for question 2, I'll do my work over here. U is equal to x to the power of 3 plus 3. I'm going to take the derivative with respect to x, where I end up with du is equal to 3x squared, and this is 0 dx. Now I want to isolate for dx by dividing both sides by 3x to the power of 2. This gives me du over 3x to the power of 2 is equal to dx. I'm going to substitute this alongside this u into my integral, where I end up with the integral of u to the power of 6, x to the power of 2, and they're all being multiplied, du over 3x to the power of 2. Once again, this x to the power of 2 and this x to the power of 2 cancel out, whereas before it was 3x to the power of 2's canceling out, leaving me with the integral of u to the power of 6 over 3 du. I can use one of the properties of integrals where I can pull out 1 over 3. I don't need to integrate that. 1 over 3, the integral of u to the power of 6 du. The integral of u to the power of 6, as before, is this expression. Therefore, f at x is equal to 1 over 3 bracket u to the power of 7 over 7 plus c. I'm going to replace u with what I set it as originally, therefore giving me the final equation shown here. Of course, I can combine these two numbers at the bottom where it becomes 21, but that's good enough. In question 3, we're asked to find the integral of x dx over 3 minus x squared. To be successful in integrating this function, we'll need to use the following rule, where if you have 1 over a variable, and in our case here it's u, your integral is ln u plus c. So what I will do is use U-Substitution and then use this property next. Here's what I mean. Of the x and 3 minus x squared, which of those two is more complicated? Obviously 3 minus x squared, because it's two terms versus a single term. So I'm going to set my u equal to 3 minus x squared. This gives me the integral of x dx over u. I'll find the derivative of u is equal to 3 minus x squared. Derivative is du is equal to minus 2x dx. I end up with du over negative 2x is equal to dx. Next, I'll substitute dx into this, giving me the integral of x over u. Dx has become du over negative 2x. The x's cancel out. I can pull out 1 over negative 2. 1 over u du. And now I can use this property to finish this off, where I have big F at x is equal to negative 1 over 2 ln u, and the absolute of u, plus c. Also keep in mind that u is equal to 3 minus x squared. So let's replace u with 3 minus x squared. And there you have it. 3 more examples on how to perform the substitution rule with integrals.